Hi, today we are going to discuss Compton effect. When a monochromatic beam of X-rays of wavelength lambda I is allowed to incident on a scattering material, the scattered beam contains radiation of longer wavelength lambda f. The difference between lambda f and lambda I is called as delta lambda. This delta lambda is known as Compton shift, and this effect is called as Compton effect. So in this diagram, we are observing that X-rays is incidenting on the electron. After the collision, the X-rays are propagating with a theta angle and electrons are propagating with a phi angle, where this propagated electron is called as a recoil electron. So in this case, the incident X-rays wavelength is lambda I and the scattered X-rays wavelength is lambda f. So in this case, lambda f is always greater than lambda I. So the difference between lambda f minus lambda I is called as Compton shift. So where that value is equal to h by m naught c into 1 minus cos theta. So in this case, the electrons are, we are assuming that they are bonded to their parent atoms, and these electron we are assuming that it is in the rest. But when X-rays are incidenting on that, it absorbs the energy and it will be escaped from the atom, and that electron or recoiled electron is called as a free particle. The collision between the incident X-rays photons and free electrons are perfectly elastic. There is no loss of energy and momentum during this collision, and hence the law of conservation of energy and momentum holds good. The Compton shift is indicated with the delta lambda, that is equal to h by m naught c into 1 minus cos theta, where the Compton shift is independent of incident wavelength and it is also independent of scattering material, but it depends on the scattering angle only. In the equation, h by m naught c is constant, where h is a Planck constant, m is the mass of the electron, c is the velocity of the light. So that value, h by m naught c value, we are assuming that is equal to lambda naught, and where lambda naught is called as a Compton wavelength. For electron, the Compton wavelength is, we are substituting h, m and c values, then the lambda naught value is 0.0243 Armstrong units. Experimental verification of Compton effect. So according to this diagram, here a collimator is there and X-rays are propagating through this collimator, where it improves the directionality of the X-rays and they are incidenting on the target material. In this case, the target material is graphite, and after the incidenting of X-rays on the target material, they are scattering. In front of the target material, we have a circular scale. On the circular scale, we have a Bragg spectrometer. That Bragg spectrometer will record the intensity of the X-rays. Using this experiment, we are placing Bragg's spectrometer at different positions, means at different angles, and we are recording the intensity of the X-rays. So the intensities are observed at 0 degrees, 45 degrees, 90 degrees, and at 35 degrees. Using this data, if we draw a diagram with intensity versus wavelength, then it is observed that at theta is equal to 0 degrees, we are observing only one peak. So it means that the Compton shift is 0 for theta is equal to 0 degrees. And next we observed at theta is equal to 45 degrees. At 45 degrees, we are observing that two peaks are there, and the peak 1 and peak 2 distance will be called as a delta lambda, that will be called as a Compton shift. And at theta is equal to 90, it is observed that two peaks are there, but the distance between the two peaks are more compared to 45 degrees. So now the Compton shift is more. And next we observed at theta is equal to 135 degrees. So where we observed that the two peaks are separated with maximum distance compared to 90 degrees and 45 degrees. It means that the Compton shift is increasing with increasing of the angle. And it is observed that the Compton shift is 0 at a 0 angle, and it is increasing. Compton shift is increasing with increasing of the wavelength. Sorry, Compton shift is increasing with increasing of the scattering angle.